Hi, this is Victoria Kabat, and this is Lab 1, Excess Charge on Ordinary Objects. So the purpose of this lab was to learn more about charges and the interactions they have with ordinary objects. By using two pieces of clear tape with excess charge, we provided a model for interactions that occur between charged objects. The systems of clear tapes are found to be in equilibrium, and the forces of electricity and gravity are found to be equal and opposite to each other, which allows us to find the charge of a clear tape, which is calculated to be 1.173 times 10 to the negative 8th coulombs. So the physics principles involved in this were Newton's second law. The acceleration of an object is directly proportional to the net force and inversely proportional to its mass. This allows us to find the magnitude of force of gravity, and then we use Newton's third law, which says that for every action there is equal and opposite reactions. This allows us to say the magnitude of the force of gravity is equal to the magnitude of the force of electricity for the tapes, and that after the distance d is moved, they are in equilibrium. The law of conservation of charge is used to define if the U-tape is positively or negatively charged by showing its attraction and repellence to different objects, and the electric field relationship and Coulomb's law are important to finding the magnitude of the force of electricity. So the experimental observations that occur with the U-tape after making the U-tape show that a U-tape and a U-tape interaction shows a repulsion. U-tape and neutrally charged objects, like a calculator in this case, have a partial attraction, and U-tapes, a negatively charged pen that was made negatively charged after rubbing it against my hair, show a strong attraction. So since like charges repel and opposite charges attract, the U-tape is positively charged. The experimental measurements used for the floating tape were that the tape length is 0.202 meters. Therefore, the mass of the clear tape was 2.02 times 10 to the negative 4th kilograms, and the distance observed between the two tapes when floating is 0.025 meters. The magnitude of the force of gravity is calculated to be 0.00198 newtons, and then this is equal to the magnitude of force of electricity, which allows us to calculate Q to equal 1.173 times 10 to the negative 8th coulombs. Then we use these calculations to find more additional calculations like excess electrons, which are found to be 7.286 times 10 to the 10th, atoms on the sticky surface per angstroms. So we use the tape's length divided by an angstrom and find that the atoms are equal to 2.02 times 10 to the 9th, and the ratio of electrons on the sticky surface is found to be 36.07. Assumptions made in the calculations were that all excess electrons are not distributed to a neutral surface nearby, that each of the tapes is treated as a point charge with charge concentrated at the center of the tape, and then each tape has the same amount of charge distributed along its length. The computational model is shown to the right, and the code involves using calculations that we've used by hand earlier. So the most important part of this model is calculating Q, which is found to be 1.173 times 10 to the negative 8th coulombs again, and the assumptions made in this model are the same as used before. So the model shown to the right displays two force arrows and then the two particles or spheres that are representing the two pieces of tape. The force arrows are equal and opposite to each other, and therefore the electric force and the force of gravity on the floating tape are equal and opposite to each other. The result summary shows that the interaction between objects in excess charge have attractive and repulsive effects. The charge of a clear tape can be determined because the system of floating tapes is in equilibrium after they move a distance d, and the force of gravity and electricity are equal to opposite to each other, which allows us to calculate Q equal to 1.173 times 10 to the negative 8th coulombs for a piece of tape. The observations and calculations would change, however, if electrons were positive and protons were negative by having opposite signs, and the model would be the same because everything would just be opposite of what it previously was. It is important to handle the charged tapes as little as possible because a transfer of charge occurs when the tape is in contact with another object. This happened a lot when I touched the U-tapes to a neutral calculator and when I charged it to the pen, because the U-tape lost a substantial amount of charge and sometimes had to be remade to show a stronger interaction. So thank you for listening, and if you have any questions, please feel free to reach out to me. Goodbye.